Okay, so for this problem, we're going to treat the lower voltage as the secondary and the higher voltage as the primary. Okay, so the voltage drop across the secondary coil of the transformer is 12,000 volts, and the voltage drop across the primary is 240,000 volts. Okay, so what we're doing is we're providing 1.4 million watts, so that means that the power going into the transformer is 1.4 million, and with that delta S, that gives us a current going into the transformer of 116.7 amps. And then as far as the output, that has to be the same. The output from the primary must also be 1.4 times 10 to the 6 watts, and so the primary output voltage must be 5.83 amps. Okay? So the idea is that you've got the input from the power plant is 116.7 amps, and then it goes into the transformer, and it comes out at 5.83 amps and 240,000 volts. It goes in as 116.7 amps and 12,000 volts. Okay? Well, then it goes down the power line, right? So this goes down the power line. And we want to know what is the percentage of power lost in the lines due to dissipation for part A. So the power lost in the power line is equal to that primary current times the resistance in the power line. So that's 5.83 squared. And the resistance in the power line is given to be 140 ohms. So that's 4,763 watts. Okay, now the percentage loss is going to be that 4763, which is lost, divided by the input, 1.4 million, and then we multiply by 100 to get a percentage, and that's 0.34%. Now for part B, it asks, what's the percentage lost if we skip over the transformer and send this down the power line? Well, that power lost is going to be the secondary current squared times the resistance. That's 116.7 squared times 140, which is too much. It's 136% of the original power, so all is lost. All the power is lost, 100%. Can't have 136% of the power lost, obviously, 100%.